Given a limit as x approaches infinity of 1 plus 5.5 over x raised to the 9x power. So my goal here is to solve for this limit, but in order to do that, I want to use a little trick where I can represent a function as e to the natural log of that function. So the function here is going to be this whole thing. So I'm going to have e to the ln of that entire thing so the exponent will come out in front of the log, and I can treat this as an exponent to an exponent. So this 9 can be the exponent of all of this. So this is what I mean. Okay. So we have exponent x ln of 1 plus 5.5 over x, and then raise that to 9th power. You just multiply those. Okay, so these are equivalent. Okay. And I can represent this. Well, actually, this limit can be part of the exponent. Right? So I can have it as e to the limit as x approaches infinity, x times ln of 1 plus 5.5 over x. And then I'm going to raise this entire thing to the 9th power. Okay, and I'm going to rewrite this. So I'm going to have ln of 1 plus 5.5 over x on the top and 1 over x on the bottom. And that's all over to the 9th power. So what I did here was I said that x is equal to 1 over x. Because now, as x approaches infinity, ln of 1 plus 5.5 over x will go to 0. And 1 over x will also go to 0. So you have a situation where it's 0 over 0, so we can use L'Hopital's rule. Okay, so we're going to take the derivative of the top. So it's 1 over 1 plus 5.5 over x times the derivative of the inside, which is negative 5.5 over x squared. And then we'll take the derivative of 1 over x, be negative 1 over x squared. Okay, so this whole thing is part of the exponent of e. Okay, so the negatives are going to cancel. X squareds are going to cancel. So we have e to the limit as x approaches infinity of 5.5 over 1 plus 5.5 over x. And I did forget to write to the 9th power here. All raised to the 9th power. So now I can solve this limit. 5.5 over x will go to 0. So I'm going to have e to the 5.5. Raise that to the 9th power will give me e to the 49.5. And that is my limit.